Hello everybody and welcome to today's video on stability of excavated rock slopes in the field. In our previous video, in episode 4, we discussed about the Q-slope equation and RQD and joint set number as the first parameters in the equation. We also discussed about the equation for steepest slope angle determination. The two parameters RQD and JN represent the overall structure of the rock mass, and their quotient, that means RQD over JN, represents a crude measure of block size or particle size of the rock mass. In today's video, episode 5, we will continue breaking down the essential parameters for the Q-slope equation. We'll continue discussing the parameters used in Q-slope equation. Before we jump into the next parameter, let us redefine Q-slope value. Q-slope value is equal to RQD divided by joint set number ratings times joint roughness number rating divided by joint alteration number rating times orientation factor for joint roughness, for the ratio between joint roughness and joint alteration times joint wall water reduction and ice reduction factor, or environmental and geological factor, divided by strength reduction factor of the slope. So in our previous video, we already have determined RQD value and also joint set number, and today we are going to discuss about how to determine joint roughness number and the joint alteration number. When we come to joint roughness number, this is the joint roughness number, and we'll get the ratings for joint roughness number from table 3. This is the third parameter, so there is table 3. We'll consider or consult this table. So geologists or engineering geologists or engineers on site on the field so can just take this table and look at, observe the joint status, the joint wall, and in order to determine the joint roughness number, you only have to observe the joint wall surface and determine its roughness condition or irregularities, correlate the irregularities on the joint wall surface with one of these descriptions. The joint roughness number descriptions are given here, and you have to correlate the joint wall irregularities or roughness with one of these descriptions. For example, in a present case, for joint set A, joints that are aligned in this direction are, so set A, assume this is a joint set wall, rock or joint wall, this face. If you see this face, I just assumed this face as I correlated this joint wall face with the C description, that is smooth undulating, and for each description there is a corresponding joint roughness rating number given. So if I correlate it with smooth undulating for joint status, for all joint status, I just observed this joint wall and correlated it with smooth and undulating, and then I will take 2 as joint set roughness number for joint set A. But we have to consider also other joints, especially the critical joints. Joint set A is the most critical one, and the second critical joint is joint set B. If we consider, for example, wedge failure in this place, so we have to at least consider the two joints, joint set A and the joint set B. So for joint set B, if joint set A I assumed it to be smooth and undulating, I will take rating 2, and for joint set B, I will consider joint set B, all joints aligned or discontinuous aligned in this direction. I consider them as joint set B, and the roughness degree is more than the joint set A. So rough or irregular undulating, I considered joint set B to be assumed it to be like this, and then the corresponding rating will be GR rating value will be 3. Like this, the geologists or engineering geologists or the geotechnical engineers working on site on the field correlated with one of these descriptions and take the corresponding joint roughness number from this table. You need to only have this table with you and then take the observation and correlate it with one of these description and take the corresponding number. Therefore, now at this point, now we have already determined RQD value, the previous episode 61, joint set number 12, and for set A, we have joint set joint roughness number 2 for joint set A, and for joint set B, we determined joint roughness number 3. The next step will be to determine joint alteration number. For joint alteration number also, we will determine for set A and set B, because we consider set A as the most critical, set B as the next critical for instability. We have to consider at least these two, because we assumed that which type of failure we expected at this slope surface. So we ignored joint set C and others because we assumed that their contribution is minor. So we have to observe this joint wall surface to determine joint alteration also. Is it altered or is it fresh or is it so like that? For joint set A, also for joint set B, we have to observe the joint wall surface whether it is altered or not. For joint alteration number, we will consider table 4. Table 4 is for joint alteration number. Descriptions are given like this. So you need to have the observation of the joint walls for set A and for set B, and then correlate it with one of these descriptions. Is it tightly healed, or is it unaltered? Is it fresh wall, or is it slightly altered, or is it silty or sandy coating? So based on the description here and your observation, then you have to correlate with one of these. And if you, for example, in our case, I just assume joint set A is correlated with D here, that is silty sandy clay coating on the surface of the wall. Assumed it would be silty sandy clay coating. It is not definitely fresh based on the observation from the picture, and the corresponding joint alteration number rating for joint set A will be 3. For joint set B, I considered it to be slightly altered joint walls, so the corresponding rating will be 2. So now we have determined joint alteration for both joint set A and joint set B. Once you determine the joint roughness and alteration, by the way, you can use this formula, empirically derived formula, to determine the shear strength along the joint planes for both for set A and for set B. You have determined the joint roughness and the joint alteration. Sigma n tan inverse of joint roughness over joint alteration will give you a rough estimate of the shear strength along the joint plane. So you can see how much important the values you derive from your observation and from this table. So now we have already determined RQD 61, joint set number 12, joint set A. For joint set A, joint roughness was 2, joint alteration is 3. This is joint alteration. For set B, joint roughness is 3, joint alteration is 2. The next will be, what we have to do is we have to go to the formula. When you come to the Q-slope formula here, joint roughness over joint alteration will be multiplied with orientation factor. Therefore, we have to determine discontinuity orientation factor, O factor. In our next episode, we will inquire further into the practical field techniques of assessing and gathering the Q-slope parameters. Thank you very much for joining today's discussion, and please do not forget to like and subscribe. Your engagement helps us bring you more valuable content. Till next time, stay safe, knowledgeable out there.